You know, Craig, I understand drum machines, but I don't quite understand MIDI and how to interface everything together. I've got some friends that can do wonders with MIDI, but to me it's a bit overwhelming. I feel kind of stupid.
Well, I wouldn't feel too bad about it if I were you, because MIDI has such wide applications in so many fields. I mean, it's not just for keyboard players. It's also for composition. It's for education. You can use it in the studio to automate your mixing. Audio for video, it has applications there. Guitarists are just starting to get into MIDI as a live performance thing with standard guitars as well as MIDI guitars. Drummers are into MIDI. So there are always new people getting involved with it. So it's getting to the point now where if you want to do anything musically at all, it really does help to know about MIDI. So it really is good to investigate all this stuff. It's not nearly as intimidating as you might think it is.
Well, I hope not.
First of all, well, I'll tell you what, rather than get into bits and bytes and buzzwords and all that kind of stuff, let's look at MIDI from a problem-solving standpoint, how to do specific things that MIDI allows for when you interface various pieces of equipment together. Okay, so I promise, no status bytes, none of that stuff.
Great.
I mean, you don't have to know how Hoover Dam works to plug in an appliance, right? So
exactly.
So this is like a nice, simple way of dealing with it. Probably, we should begin with why MIDI got started.
Okay.
Because MIDI just didn't come out of nowhere. MIDI was designed to solve specific problems. So we need a little bit of electronic music history here, going back into the dark ages of the late 70s and early 80s. There were several problems associated with the technology at that time. One is that it was expensive. And so manufacturers, because synthesizers weren't that common, would tend to make synthesizers that were complete units, a keyboard, the case, the power supply, the sound generators, all that stuff, which ended up being fairly expensive. Now, if you wanted to trade in your old model for a new model, you'd have to essentially get rid of the entire system and start all over from scratch with a new keyboard. There wasn't anything you could use from your old system, so that was a pretty expensive process.
Sure is.
The other thing was, because electronic music equipment had started off as a sort of a minority thing, in the sense that it wasn't very common, it was kind of expensive, it was limited to universities and a few other very specialized applications. It wasn't a very commonplace type thing. So you had all these different manufacturers going in somewhat different directions, and they would be working on something and not know what another manufacturer was working on, so they would all design their own consistency standards on how to hook gear together. But it didn't mean that you could hook gear from other manufacturers together. What made this a real big problem was that musicians discovered early on that analog synthesizers of that time tended to sound a little thin by themselves. So what they liked to do was layer multiple sounds together, like a brass sound and a violin sound at the same time to get an orchestral effect. And a lot of times what they would have to do is have two physical separate keyboards sitting there, playing one with the left hand, one with the right hand, playing unison lines to get the same sound. Now that's really pretty inefficient and pretty expensive. It also meant that if you wanted to have 6 different sounding keyboards, you had to have 6 different keyboards on stage. I mean, it was a roadie's nightmare, if nothing else. So anyway, these companies did come up with ways to interface their own synthesizers. So you could take 2 Moog keyboards, for example, and hook them together and be able to play one keyboard and have it trigger sounds from the second keyboard.
Right, okay.
Okay, so, but it was a non-standard protocol. If you went out, and let's suppose you like the sound of a Moog synth, but you also like the sound of an ARP synth, so you went and you tried to hook them together, they didn't work. You'd have to make some little adapter box and get some tech to sit there with a soldering iron, and this is not exactly the stuff of which mass market dreams are made, right? So that was one problem. There was the obsolescence factor, which was just as strong back then as it is now. But the difference is now, you can get a drum machine for what, $400 or something like that, and a synthesizer for under $1,000. So if you wanted to add another synthesizer now, it's not quite as big a deal as like spending another $5,000.
Right.
Okay. Yeah. So musicians were kind of reluctant to turn over their technology and essentially get rid of an entire old system and replace it with an entire new system. So that was pretty inconvenient. Alternate controllers were very difficult to do In other words, it was simple to hook a keyboard up to these synthesizers, but if you wanted to play guitar or drum controllers or whatever, they usually had to be custom made to work with a specific company's synthesizer.
Now, a controller is something that controls another device, like a keyboard would control.
Yeah,
something.
actually, controller is one of those wonderful words that has many meanings depending upon the context. But we'll be looking at two basic meanings. One is a controller is a device that you perform on, like a guitar controller, or a keyboard controller, or a drum controller. But there's also another type of controller, which is a physical knob or slider or something like that that controls an aspect of the sound, a foot pedal. Those are also called controllers. It'll be pretty obvious when we're talking about it what the differences between the two are. You know, you'll see as we go along. But yeah, that's that is a point that confuses people sometimes.
Yeah.
So alternate controllers were a problem. Synchronization was a complete disaster because all these companies had different standards, and so like you'd hook up a drum machine to a sequencer and it would be going half time or double time, or if you could get it to start at all, or they wouldn't maintain synchronization after they'd started. And this was producing sort of chaos in the music business.
I should think so.
Oh yeah, and it was hurting manufacturers too because it was a very unsettled market, and people were very dissatisfied. Well, I get this thing and I get this other thing, and they don't work, and then they go to repair people, and so
big mess.
Big mess. Big mess. So amazingly enough, a bunch of manufacturers got together, and originally there was a standard called the Universal Synthesizer Interface. And this was developed by the folks at Sequential, and it was presented at an Audio Engineering Society convention as a way to separate the controller from the sound generating circuitry. And the rationale for this was that if you wanted to buy a new synthesizer, you could keep your keyboard and just get a new sound generating device.
Well, that's
and there would be a
great.
standard way of getting note data from the keyboard to the sound generator. And so if you had a keyboard that's made by company A and a sound generator from company B, and then you decide to buy a third generator from company C, they could all be hooked together and work just fine. So this solves several of the problems. One is all the redundant keyboards on stage.
Right.
You only needed one keyboard. It cut the cost way down because obviously a little rack mount unit is going to be a lot simpler to manufacture than something with a big case and a keyboard and all those mechanical parts and all that. And it also helped prevent some of the obsolescence factor, because now you could just get the parts you needed to improve your rig and your sound. You didn't have to go for these other things. And they also decided to come up with a signal process, with signal processors that could be controlled in the same way, which we'll be getting into later.
Okay.
Anyway, this spec was basically looked at by several companies, and quite a few Japanese and American companies contributed their ideas to this initial spec, and that grew into MIDI. And I should add that it's sort of an amazing political statement about the music industry that all these competing engineers from all these different companies were willing to get together for something that would actually do some good. I mean, if you look what happened with 8-track versus cassette and beta versus VHS and all these different, try to take a disc from one computer and put it into another computer. And it's just really, there's so little standardization in the world that we as musicians have really been fortunate that this whole MIDI process, that it came about. And not only that, but the specification continues to be refined to this day. There are new additions being made to it, and this is all being done as a concerted effort with unanimous agreement by all the manufacturers who are part of the organization that takes care of the MIDI spec. So what this ensures is that they try to make sure that any future developments are backward compatible with what happened in the past. And you can still use a 1983 keyboard in a 1991 MIDI setup, which is really pretty remarkable if you think about it, especially contrasted to computers or something like that.
Right.
So
what does MIDI stand for?
Well, MIDI stands for Musical Instrument Digital Interface.
Okay.
But you don't need to know that.
I don't.
No.
Okay.
No. MIDI, you can just think of MIDI. Well, let's tell you what MIDI is, okay?
Great. Yeah.
MIDI is a language, a computer language that expresses musical concepts, musical performance data, the status of a musical instrument in numeric terms. In other words, everything that you do is translated into numbers.
Okay.
Now, a lot of people at this point wonder, well, what does numbers have to do with an artistic experience? We're talking about feeling and grooves, and you're talking about the square root of pi or something, right?
Right, yeah.
But if you think about it a second, everything you do musically really does relate to numbers. Like when you tune to A440, where 440 is the number of cycles per second, right? Cycles per second, another mathematical concept. What's your tempo? 120 beats per minute.
Right.
There's another fraction you're dealing with. What notes are you playing? Eighth notes, 16th notes. Okay. What about vibrato? Well, that's like a 7 hertz to 10 hertz frequency. See, all these things, you are dealing with numeric concepts. Even when you're talking about something like noise, you're talking about a signal-to-noise ratio of so many dB.
Right.
So as it turns out, music and mathematics have been getting along famously for centuries. I mean, since Pythagoras, and probably before that. We just don't have records of it.
Right.
And so it's not at all illogical that you would be able to express all the performance parameters of playing music as a number.
Sure, and then capture it some way.
Well, capture it, analyze it, change it, mess around with it. Now see, this brings up a very important point. Inside of almost all contemporary keyboards, drum machines, signal processors, and all that, you have a computer. And what computers do is they crunch numbers. They can't think very well, but they can sure crunch numbers real fast. So since there's all this computer power in there, and since we're expressing music as a mathematical thing, they just go together like hand and glove. But again, you don't have to concern yourself with what those numbers are or how the process occurs or anything like that. All you have to know is that on the average MIDI instrument, you'll have a MIDI in and a MIDI out and optionally a MIDI through.
Okay.
Probably where we should start is at the MIDI out.
Okay.
Let's take a look at this keyboard here. This is, in fact, as proof that you can get MIDI to work with different manufacturers' stuff, we have a liberal assortment of Alesis gear. We have a drum cat. We have an Ensoniq EPS. We're going to be having a MIDI guitar later from yet another company, and they all work together just fine because they all have the MIDI connections.
Right.
Now, those MIDI connections, you're already familiar with what the audio connection on a musical instrument is. In other words, let's say you have an electric guitar. You play a note, it sends out note data over the audio, except it's not expressed as numbers. It's expressed as a waveform that you can see on an oscilloscope and hear and amplify and all that, okay? So that's what's coming out of a guitar. Now you also have a power cord, and that's basically power in on your keyboard, right? There's power coming out of the wall and it's feeding the juice in.
Turns it
so you
on.
got power, you got audio. MIDI's just another cable, but it doesn't carry audio. It doesn't carry power. It carries musical information as a stream of numbers, this constant stream of numbers that's coming out.
Okay.
So let's take a look at some of the MIDI language that you would have appearing over this cable. When you play the keyboard, well, let's play a note here. There's a middle C.
Okay.
Okay. As soon as I press that key, a piece of data goes out the MIDI out that says a C has been played and this is the note. Now, MIDI numbers each note, and middle C just happens to be a note number of 60.
Okay.
Now, of course, that may show up on different places on different keyboards. If you transpose it an octave, if you transpose this whole keyboard down an octave or up an octave, the note will show up in a different place. But middle C is always 60, and then it goes down an octave from there. The next C down would be 48, 36, and so on.
Okay.
So when I press that C, as far as you know, you've played a C. As far as the computer is concerned, note number 60 has been turned on. Okay? When you release the key, it sends out another piece of data that says this key has been released. Now think about what's happening if this is a master keyboard and you have a little sound generator off stage with a MIDI in. Now that MIDI in is constantly reading what's coming in on that line. So if it sees a message that says a C has been pressed, it will play a C just as surely as if you pressed a keyboard key, because it's getting that data that says turn the C on. And when you release the key, it turns the C off. Now, while we have a particular program loaded into the sampler here, also called a patch, sometimes called a patch.
And why is it called a patch, though?
Okay, here's another thing of confusing terminology that's changed over time. It used to be with old synthesizers that they were strictly modular devices because they were so expensive. You'd buy like an oscillator and then you'd buy another oscillator, and then you'd buy a filter, and then a little mixer to mix them all together. And because they were so undedicated to a specific function, you'd have to hook these things together with patch cords, like an old telephone exchange.
Right.
So after a while, they were just called patches. You know,
You're
what kind
patching
of patch?
wires here and patching wires there.
Now these days, your patches are done in the computer. You're saying send this module to this module, and you don't even, it's a completely transparent process. You don't even have to think about it. So more and more, people are calling what used to be called patches programs.
Okay.
And what a program consists of is a whole string of individual parameters set a particular way. For example, if one sound, one parameter might be the brightness of the sound, or the pitch of the sound, or the tuning offset. You know, these are all different parameters. And by setting them the way you want, you can come up with a program or a patch. And in most synthesizers these days, you can store that program in memory. So you can just hit a couple buttons and get all the work that you've put into changing those parameters back in a second, instead of having to switch patch cords and turn knobs and all that stuff.
Much easier.
Okay, so you have your program selected on the other synth.
Yeah.
The MIDI out goes to the MIDI in. You play the note. It sends the note. The other thing responds. Cool so far, right?
Very simple.
But there's much more to it than notes. Now, the program I have in here is a sample of Maurice White from Earth, Wind & Fire doing vocal sounds.
Okay.
And there's a couple different programs in here. But let me show you some of the other aspects of the MIDI language. In addition to turning a note on or off, part of the data that also goes with that note is the velocity with which you strike the key. And this usually correlates to dynamics. Now this confuses some people. It's like, what does velocity? I don't see this thing moving, right?
Right, yeah.
But it is moving because you're going from a key up to a key down. And so what velocity measures is the time it takes to go from the key up to the key down. So if it takes a long time, it assumes that it's a low velocity value.
Okay.
And so the dynamics are low. Whereas if you hit it real hard, it goes down fast. So that'd be a high velocity value and translate into higher dynamics. One of the beauties of MIDI is that you don't have to always have velocity control dynamics. It could control filter brightness. It could control detuning. It could control anything that you want to assign it to. Traditionally, it's used to control dynamics, but that doesn't mean you have to do it. Now, here's another thing you can do. There's a this keyboard has a pressure response, which means once the key is down, you can press on it and produce more data. And in this particular program, what it does is it changes the amount of vibrato.
Okay.
See how I'm pressing it and more vibrato is coming out?
The harder you press it, the more vibrato you get.
Right. And that's part of so the velocity and the pressure and all that, you can vary, and the note, of course, just by playing specific keys on the keyboard. Now, furthermore, there are other performance things that you might want to use live, like, well, consider a foot pedal, for example. A lot of times a foot pedal is good for fade-in and fade-outs and stuff like that. So in this particular case, it's programmed to act as a volume control. So you can do swells and fades and stuff like that.
Okay.
Meanwhile, it's sending pedal data through the MIDI out port. So if another unit can respond to the pedal, it can be turned on and off along with this one.
And each of these things you're doing is represented by a number.
Right.
Just like middle C was.
Right. The difference is that, let's talk a little bit about what a MIDI event is. When you press the key down, that's one event. When you release it, that's another event.
Okay.
With something like a foot pedal, as you sweep it through all the possible states, it's going through a lot of different events. It's going from full off to full on. So typically, sweeping a pedal or something like that is going to generate more MIDI data than just playing notes.
Okay.
So that's a little bit of a subtlety there. But in any event, there's a lot of stuff you can send down the MIDI line at one time. It goes at a very fast rate. In addition, there are these performance controls like pitch bend and mod wheel. That's real common on most synthesizers. What the pitch wheel does is it lets you actually vary the pitch of a note, which is good for lead guitar sounds and bending up to pitch on a wind instrument, or special effects like that.
Right.
And again, this is all getting sent through the MIDI out. Modulation wheel. This is another, on this particular program, it's another way to add vibrato.
Oh, okay.
Now remember I mentioned programs before? This particular keyboard here, the EPS, has what's called patch select buttons that let you select any one of 4 different programs sort of instantly without having to key them in. So like here we have an ooh sound. This patch is an ah sound. More of an eh sound. So that's how you send out different programs. And again, that data is going out, the MIDI out. So you're starting to see how this keyboard, the keyboard itself is not making any sounds, remember? And, and MIDI's not making any sounds. The keyboard is simply generating numeric data that mimics your playing. And it sends it, of course, to the internal sound generators in here, but then it also sends it into the MIDI out port.
So it causes you have the MIDI information going out the MIDI out, and then the audio information going out the audio out.
Right.
So you can hear what you're playing as well as send the information out to another device.
Exactly.
Okay.
And you know, it's real handy that way. The MIDI in is pretty obvious from what we've been talking about. The MIDI in receives that data and responds to it. The MIDI through, all that does is it carries a duplicate of what's at the MIDI in. And we'll see why when in multiple systems where you have numerous pieces of equipment hooked together, that becomes important because you want to be able to send that data to several pieces of gear. So we'll be getting into hookups in the next part. But that's the third connection. It's according to the MIDI specification, it's an optional terminal. In other words, not every piece of gear has to have it. Okay. But MIDI in and MIDI out are the biggies. Now, some gear gets around this problem, especially some of the Alesis stuff, by having switchable MIDI through or out. So you can turn it into a through connection or an out connection depending upon what you need for your system, which is a clever way to get 3 jacks work out of 2. And it's much better than leaving out the through jack entirely. You can sort of choose what you want. So there are some variations in there. And in fact, speaking of variations, I should say that because the MIDI spec is so wide-ranging and offers so many different forms of control, not just what we've talked about here, not all pieces of equipment implement all pieces of the MIDI specification. For example, this keyboard produces pressure. Other keyboards don't. They don't produce any pressure data at all, but they will respond to pressure data coming in, or they might not respond to pressure data coming in.
So all the options are out there. Whether the company that develops the product chooses to use them all or not to use them all is up to them.
Yeah, and it's also a question of expense. How much you can bring a product in for. I mean, if you start going nuts with the software and having it do everything that's possible, that's obviously going to cost more. And the other thing is that some things are just not important, like if you have a keyboard that's just designed for live performance and doesn't have a sequencer or drum sounds or anything like that in it, who needs timing data? True. Okay, let's talk about some other aspects of the MIDI specification. We talked about the performance stuff, the notes and all that. Let's look at program change a second. Now I have, in the rack over there, I have a Quadriverb GT, and you were wondering.
I know the Quadriverb, but I'm not sure about the GT.
The GT is a brand new unit. In fact, it's so new it doesn't exist in the real world yet.
So this is the other world.
This is a prototype that I managed to steal from the Alesis R&D people for this video, so we can have something hot and new and happening here. But it's not actually a finished model, but it'll serve the purposes. Now, what it is it's a Quadriverb that has a whole analog section for guitar players, and so we'll be doing some guitar stuff later. So rather than switch units around, I thought, we'll use this. And they said, but it's not finished. And I said, that doesn't matter. So anyway, so we got the Quadriverb in there. Okay. And what I want to show you is that there's a concept called program change. And the way this all started was because you have, let's suppose you have your master keyboard on stage, you have your sound generators off stage. If you change your sound on your master keyboard, how are you going to change sounds on your remote sound generators?
With a long stick?
With a very long stick, that's exactly right, called a MIDI cable. And that very long stick carries program change information that says, aha, a program has been changed on the master keyboard and I will change to the program I'm supposed to change to. Now, you're not just limited to doing this with sound generators. Signal processors can do that as well, because you might have, for example, on program 1, you might want to have a real long echo, and on program 2, a chorus effect, on program 3, a big hall reverb. And again, it would be very inconvenient to go over and reset the Quadriverb each time you wanted to do something like that. So it will respond automatically to a program change on here. Now take a look at the quadriverb, the GT screen there for a second.
Okay.
Right now it's on program 0 there, which is an echo chorus delay reverb. That's what's giving this reverb sound here. Now let's suppose that we want to have more of a mellow chorus sound.
Okay.
What I can do is call up a program change on here. Now it's just changed to a stereo chorus. Now when I play, I've taken the brightness off a bit, and you know it's a little bit mellower, and the chorus effect is more pronounced, and there's a lot less reverb. Now I can there's another. Let's call up another program here, and this one puts Maurice into deep space. It uses the ever popular ring modulator effect on the quadriverb, and gives some real spacey sounds here. A bit eerie, but that just goes to show, I mean, what a wide variations of sounds you can get with just one button press, and it's right there. If I had to go over between songs and retweak all the settings on the quadriverb to go from the stereo chorus to the ring modulator, I mean, you know,
it wouldn't be, it wouldn't look too good on stage.
No, it wouldn't. Everybody would get bored.
Either.
They'd leave. The band would never get signed. You know, it might be good for the bar. People would go over and take a break or something. But that's about the only benefit I could see.
And the way you got the program changes to the Quadriverb GT was by pressing a key on the keyboard, or is there something else you did?
Well, there's a lot of different ways you can do it. In synthesizers, generally what happens is as soon as you call up a patch or a program, it sends that data down the MIDI line. On the EPS here, you can leave the same program on the keyboard and enter a specific program change using this number keypad. So you can just enter like program 99 or 36 or whatever. And that's because this is a sampler, and samplers tend to have less programs on board at one time. So you might want to be able to add different effects to the same basic program. So this allows you to do that.
Okay.
Okay, so that's what the program change thing is all about. Other units might allow you to just increment with every press of a foot switch to go through the programs that way. So if you have something set up on stage where you have a specific order and you know you're going to be doing things in a certain way, instead of having to call up program 32 and 5 and whatever,
just step through it.
A foot switch, right? But I should also tell you about the MIDI consumer weirdness alert, which is every now and then you'll run into little parts of the MIDI specification that don't quite jibe in one way or another. It's usually not a technical problem. In other words, you'll still get the program change, but sometimes the nomenclature is different from unit to unit.
Okay.
For example, on the EPS, well, there are 128 possible program changes.
Okay.
The question is, some manufacturers number their programs as 0 to 127. Others number it as 1 to 128. Still others break it into groups of banks. Like Bank A might have patches 1 through 8, like A1, A2, A3, A4, all the way through A8. And then you would switch over to Bank B, which would be B1, B2, B3.
Up to 128 or whatever they chose.
Yeah, it would be like, you know, M7 or whatever, you know, M8 or whatever would be the last patch. So that's a little bit of a complication right there. In fact, if you looked real closely, you could see that to call up program 1 on the Quadriverb GT, I was sending it program change 2 from here. Because the EPS numbers from 1 to 128 and the Quadriverb
0 to 127.
Right. But you'll find that it's not really as big a deal as you might think, because after a while you just sort of get mentally used to saying, oh yeah, this is a unit that does it this way, and it's not like there's one that's a lot more common than another either. There's a pretty good mix and match between them, and the bank thing is starting to pretty much go by the wayside now, although there's still some units that number things that way. So that's one thing that you need to be concerned about. Another possible problem occurs. Well, not a problem so much, but just something you need to be aware of. Suppose you have a signal processor or a sound generator that only has 64 programs in it instead of all 128. What happens if you send it program 65? What happens if you send it 72? It might double back and go through that same group of 64 again, you know, where 65 would call up 1 and 66 would call up 2. It might ignore it. It might go into hyperspace if it's a really old unit. You know, it might do any one of a number of different things. So what I like to do when I get a new piece of gear is I have a little test sequence made up that sends out program change numbers, and I just look at the display and see what gets called up.
Right.
And I have a little reference card that says, okay, this unit goes from 0 to 127, or this one does banks, or this one wraps around after 64, or whatever. So you should be aware that there are some little complications like that. Another complication occurs if you have something with 300 patches. What happens if you want to call up patch number 276? Now, there's two ways around this. One is a fairly new aspect of the MIDI specification called MIDI Bank Select. What MIDI Bank Select does is it allows you to choose banks of 128 programs.
Oh, okay.
So that's one way. That's very new, though. It's not common at all. Just a couple pieces of gear starting to come out with it now. Like I said, the MIDI spec is constantly evolving.
Right.
But this is but again, this also points out something, which is that these banks are still in groups of 128.
Right.
So you're not obsoleting everything that came before. You can still access the first bank just like before, and if you have a piece of equipment with bank select and your master can't generate that, just select the bank on the piece of gear, and you can still select any of the 128 programs within that bank from your old piece of MIDI gear. And I think that's very considerate, frankly.
That really, I agree with that.
Now, there's another way around that problem, which is called mapping. What mapping does, in fact, this is a feature that's in the quadriverb. It lets you redirect an incoming program change and translate it to a different number. So you can set it up on the quadriverb so that when it sees program change 2 coming in, you can set up a little table where it will call up program 33 or 46 or whatever in the quadriverb. And this is very much, it's like a little table, one from column A, one from column B. You set up what program is coming in and what program you want it to call up. And as long as you have table turned on,
right,
instead of just program change on or off, it will translate things according to that table. Now, believe it or not, this is actually getting into pretty esoteric stuff. But is it making sense so far?
Yeah, it really is. It's not as confusing as I thought. I at one point thought of MIDI as audio information, and thinking if I played a chord, it would go out the MIDI port and appear in a pair of speakers. But that's not true. It goes out as data and then goes to a sound source and then appears as a sound on speakers.
Right. That numeric data has to be converted into something we can hear. Think of it like a CD. I mean, a CD doesn't record sound, it records numbers.
Right.
But there's a little mechanism in there, or a circuit, I should say, that translates those numbers and reconstructs an audio signal from it. And it's the same kind of thing here. When you send that MIDI data to another sound generator, it reconstructs your performance based on the data that it gets. In fact, another application, a very popular MIDI application, is called sequencing. And all this means is that you send the data into something like an MMT8, which is a pretty common 8-track sequencer. And what it does is it remembers the data that it received and the order it received it in. So if you press down a C, it remembers that a C was pressed at this particular time in the song, and so forth. Now, if you take the MIDI out from the sequencer and plug it into the MIDI in of the sound generator, it'll just play that data right back in. It's just like a player piano. It's like a high-tech player piano.
Oh, okay.
But instead of having a piano roll that's like punched with holes, you have memory that's punched with data.
Okay.
Okay, so you punch your data in memory, you send it back in. You just don't see the keys move up and down. But aside from that,
That's too bad.
Yeah, well, they're working on it. But anyway, you do get this basic kind of high-tech player piano effect with a sequencer, and that's all a sequencer is. See, people originally got confused because they tried to relate it to a tape recorder. And it's not really the same thing. It's just storing your performance data. It has nothing to do with sound.
Right.
Just storing the nuances of your performance. That also means, though, that 5 years from now, when you sold this keyboard and gone on to something with 32-bit sampling and 4 gigabytes of memory or something like that, you can still take that original sequence, put it right into the MIDI in, and you'll get your performance recreated. Maybe with hotter sounds or different sounds or better sounds or whatever, but your performance is still right there. I mean, it would have been really great if this had been around in the 18 and 17 and 1600s, Then they wouldn't have to have arguments about how Bach really wrote his music, right? But anyway, so that's So far we've got the performance type thing. We have some of the housekeeping ideas about the program changes to make your life easier. There's also a whole aspect of the MIDI specification that relates to synchronization. And this is a most wonderful addition because synchronization before MIDI was a really hit or miss proposition. And this really just cleaned up the whole world of synchronization. MIDI synchronization confuses a lot of people. But the basics are very simple. What usually causes problems is if someone has something set to receive something it shouldn't be receiving, or has some kind of MIDI feedback loop set up where it's receiving two different tempo sources or whatever. So try to ignore all the bad news you've heard about MIDI sync and just focus on the fact that there are really only a few important aspects of it.
Okay.
Now, as an example, let's assume we have the SR16, which is a drum machine, and the MMT8 sequencer hooked up. These are both rhythmically oriented devices. And if we have them playing together, of course, when the SR16 is playing measure 8, we sure want the MMT8 to be playing what's recorded in measure 8 as well.
Right.
Unless you want to get really avant-garde, you know. But generally, you want to have these two things synchronized together.
Yeah.
So what happens is one becomes the transmitter, the master of this relationship. The other is the receiver or the slave. If you want to start a sequence, there's a start command. And when you start the sequence, it will tell the drum machine to start playing its pattern. When you press stop, it will tell the drum machine, you'll never guess this.
Stop playing its pattern.
You got it.
I feel smarter already.
Hey, isn't it wonderful? MIDI raises your IQ if you do it right. But anyway, one interesting thing about the stop is that when it stops you at exactly the point where it stopped. It doesn't do anything more. So like if you stop at the end of the fourth measure, it just sits at the end of the fourth measure. Now from there you can do one of two things. Either you can press start, in which case it goes back to the beginning, starts from the beginning, or you can press continue. And what continue does is it picks up where you left off. And you'll notice here on the MMT8 that in addition to the track selection and other buttons, that the three main buttons here you're dealing with are play, stop, continue, and record. So what stop continue means is you can stop it, and if you hit it again, it will continue from that point.
That's a handy thing to have.
Oh yeah,
really.
Yeah, it really is because well, there's a lot of situations where you might want to, if you're doing a song, you don't want to have to go back to the beginning each time. If you want to like just work on the chorus or something like that, where you want to stop it and then maybe go back a few measures and continue from that point. Whereas start would always kick you back to the beginning. See, like again on the MMT8, you can fast forward or rewind through the sequence. Go ahead a few measures or back, and then if you press continue, it'll pick up from wherever you stopped.
How does it know, though, really where it stopped? If it's the 8th measure on the sequencer, how does it know to tell?
How does the drum machine know to
start on the 8th measure on the drum machine? How does it know that?
Well, that's the remaining piece of the MIDI sync puzzle called song position pointer.
Okay.
And this is the most wonderful part of the MIDI spec in terms of timing because it allows for very cheap, inexpensive, easy auto location between different units. What song pointer does, all it does, again, let's look at the MMT8 as a master. When you press start on that, there's a little counter inside that keeps track of how many 16th notes have elapsed since the beginning of the tune.
Okay.
So let's suppose you're about to start playing a tune. You have these hooked up properly. You have the MIDI out from the sequencer going into the MIDI in of the SR16. You press start on the MMT8, goes into the SR16, and the two sequences start playing. The phone rings. You hit stop.
Right.
Okay. And then meanwhile, your dog ate the SR16 or something, changed the pattern, you kicked the AC adapter out when you ran over to the phone or something like that.
Right.
The MMT8 still knows where it is, but the SR16 at this point it could very well be lost. You might have been reset back to the beginning or anything like that, so how do you get it back? Well, remember, the MMT8 has been keeping track of how many 16th notes are in there. When you press continue on that, before it actually continues, the first thing it does is it sends out the song position pointer message to the SR16. And the SR16 says, oh, where am I in the song? Gets the message, sets itself to that point, and then continues on from that point. So what this also means is that you can start, again, a situation where you're just saying, you're doing an overdub on the very last chorus of a tune, and you're recording a part into the MMT8. No problem. You can just like go to that particular point in the song, press continue, and the SR16 will pick up each time from that same point. It used to be in the old days, before you had song pointer, you'd have to start a sequence and a drum machine from the beginning each
Every time.
even if you just want to overdub the last 2 beats.
Wow.
So you'd have to sit there, and you'd fall asleep, and then you forget to do it, so you'd have to go back to the beginning again. You'd have to, you know, and I'll tell you, if you just have to like really overdub one critical drum hit or something, waiting for 3 minutes to do that one hit, the odds are that you're going to blow it.
Right.
But this way, it's just a lot simpler. And that's really all there is to MIDI synchronization. The problems that people have is that something like a drum machine like the SR16, it can be the MIDI transmitter or the MIDI receiver. In other words, you could have this drive the MMT8, you could have the MMT8 drive the SR16.
Okay.
Now also the EPS has a sequencer inside that. So you could actually sync 2 of these sequencers to the drum machine, or have the EPS as the master driving both of these, or have the SR16 driving both these sequencers, or whatever. And the problem is that if they're all set up to transmit MIDI information, and they're all set up to receive MIDI information, timing information, you know, they'll all be trying to drive each other and drive each other crazy.
Going across the MIDI cable.
So you just have to make sure that you have it set right, that, you know, if you have all these MIDI cables connected, that if this is the master, this is sending out MIDI data, you know, MIDI timing data, but it's not listening to what's coming in, and these are set only to listen and not send, and that sort of thing. That's where most of the problems come in. It really has nothing to do with the MIDI sync process itself, which is pretty close to fail-safe.
Just operator error, basically. You need to know what you can and can't do with.
And knowing the
unit.
machine.
Right.
You know, in fact, one thing I should mention before we move on to the next part is that most people think of synthesizer programming as something kind of difficult and abstract. But it's getting to the point now where it's all pretty standard, where you have different menus that relate to different aspects of the unit's operation, like timing or MIDI or whatever, and then different pages within that menu. You know, like let's suppose you have the MIDI menu called up. Well, one page might be, am I supposed to respond to timing data or not?
Right.
Am I supposed to be outputting note data or listening to note data? You know, that kind of thing. Each one will have a page, and then on each page there's a parameter, like on or off, or a value from 0 to 127 or whatever. And generally, the process of programming is you just work down. You find the menu that contains the function you want to change. You find the page that contains the proper parameter. You change the parameter.
Change them all one by one until you have what you want.
Until you have what you want. It's the same thing for the quadriverb. You know, if you look at the way the buttons are laid out on that, you see it says like reverb, delay, pitch, EQ. Well, those are all the different menus. So if you want to change the EQ, just press the EQ button, and then you see the page.
Right.
The page buttons and the value buttons. Page gets you to different pages in the menu, and value changes the parameter value. Piece of
Simple
cake.
as that.
Same. Yeah. It's the same thing on the EPS. You call up, you have different pages. I mean, it's harder to see here, but you have different menus. You call up different pages. You find different parameters. You adjust them.
I guess the word menu is something we're all familiar with.
Oh yeah.
True.
Yeah, it's the same thing here. Like, look at these buttons. You have drum set, record setup, MIDI setup. And again, these are all things you can look at. Well, here's a real good example. Let's look at MIDI setup. Okay, there you can set MIDI channel, which we'll get into a bit, and you can go through different pages. And do you want the drum notes being sent out?
Right.
How do you want to assign notes? Do you want the clock to go out, or all that stuff? And then you can vary the actual values with these parameter buttons. So it's getting to the point where even if you come to a unit cold, and you don't, or there's a sketchy manual, or a manual written in...
There's never sketchy manuals out there.
Especially if it's written in a language other than English. Usually, if you know to look for menus, pages, and parameters, you can sort of muddle your way through. If there's a button labeled MIDI, try pressing that if you need to change the MIDI thing.
Right,
See what happens, So anyway, I just wanted to get that in. So, are you pretty clear on what MIDI's doing so far?
Yep. Basically, what I understand is that when you play a chord on your keyboard, for example, MIDI information is sent out the MIDI out port, which is then sent to a MIDI in device, which then figures out how to translate it depending on how you have set it up previously, or how its factory defaults are set up. And also that you should really learn your gear, learn its little nuances, and play with it a little bit before you go and get involved in a real big project.
Oh yeah, that's a real important point because, well, just let's take signal processors as an example. Some will only respond to program changes. So you can move the pitch bend wheel all year, and there's nothing that it will do to the sound. Another unit might respond to pitch bend, but unless you've set a parameter to be controlled by pitch bend, it's not going to make any difference.
Right.
So you actually have to know those kinds of ins and outs and throughs, I suppose, in this case. And the more you know the piece of gear, the more you'll be able to do with it. But I should also mention, I know that the intimidation factor is something that really kind of boggles people, and they get something like a quadriverb and they go, oh gosh, look at all these pages and menus and parameters and stuff like that. But the thing is, once you've sort of figured one of those things out, the learning curve is steepest at the beginning. The learning curve for MIDI kind of, goes up real, I mean, it's like a real steep curve at first, and then you start seeing more and more commonalities between different units.
Right.
And then after a while, you can just sit down to something you've never seen before and make it do something useful. So, don't get discouraged in the early part, because that's the hardest part. It's like playing guitar when you don't have calluses yet.
Right.
Once you've built up your calluses, then you can play, as much as you want.
And I'm sometimes afraid of mathematics because it's such an overwhelming subject and you can do so much with it. With MIDI, it is very mathematically involved, but you don't see that aspect of it.
No, the only part
Everything is handled through a cable. You don't see it. You don't adjust bits and bytes.
Oh, no. You never have to get in there and well, I mean, you can if you're a serious MIDI hacker and you want to go around customizing things and stuff, you can get in there. But for, normal humanoid biped musicians types, you don't really have to think about that stuff at all, because that's what engineers are getting paid for. It's their job to figure that out. The only numbers you have to remember is gee, program 60 is the one with the great brass sound or something like that. And I mean, of course, there'll be some number adjustments like pitch bend range. Do you want it to go 5 semitones or 2 semitones or whatever? But those are numbers that we're all used to dealing with. The important thing is, you don't have to worry about the number of bits that are being sent out. You don't have to worry about the timing or anything like that. That's all taken care of for you. It's a musical instrument. I mean, it's important to never lose sight of the fact that the whole reason why MIDI exists is to let you hook a bunch of stuff together into a system. And it's supposed to make life easier for you.
And let you be more creative.
Exactly. And it should. Now, granted, when you're first getting started with it, you'll do things like, you'll be trying to trigger the drums from the keyboard or something, and nothing will happen, and then you'll forget that you forgot to, you didn't turn on the drum notes in, or you forgot to set them to the same channel or something like that. But after a while, you'll start to develop sort of a stable setup, and boy, you can just turn that thing on and be making music within minutes, and recording it into your sequencer and triggering signal processor changes and all this stuff. And of course, it's great for live too, which we'll be getting into a little bit. Great.
Well, I really appreciate you making me not feel as uncomfortable about MIDI.
Well, again, it's a little difficult at first, but just hang in there, because the more you play with it, the more it becomes obvious. And after a while, it's like a logarithmic type of response. It's just past a certain point, everything just kind of clicks in your head, and you go, yeah, I got it. And then you become really the master of this whole thing.
Great.
So I think maybe, okay, now you have the basics down, you understand the concept of data, you know that we're not dealing with audio when it comes to MIDI, but with numbers that are going out, and the performance data, the program changes, synchronization. That's really the essence of the MIDI specification. Now I think what we need to get into is how to hook things up, and also MIDI modes and channels, which still causes a lot of confusion with people.
Great, let's do it.
Okay.